Welcome everyone. So I'm Richard, that's Tobias. We are both working for the Gnosis Safe, and today we want to talk a little bit about our experience when developing a smart wallet and like the interplay of UX and contract design during this process. So first, I wanted to give for that a very brief history on Gnosis smart wallets, because Gnosis developed one of the very first smart wallets, and the question is, why did Gnosis do that, right? So it all started in 2017 when Gnosis was preparing their token sale. So there were a lot of people, or like there were a number of people involved in this token sale. There were the founders from Gnosis, there were some management personnel from Gnosis, and then we had the consensus people, and all of them together had to manage this token sale and the funds that are involved in the token sale. But it should not be that they have one private key that they just share, and then everybody of them, each one of them has full access to all of the funds of the token sale. It should be more something like, okay, we have like a majority vote to use one of the, to use the assets. Also, it was expected that there would be a lot of assets involved, or like a high value assets involved in the token sale. So there was a high security requirement on this smart wallet. So that's why Stefan, one of our founders, actually implemented the first Gnosis multisig, and already this Gnosis multisig had the very core features that we still have today as like for our multisigs, for our smart wallets. And the first one is that you have a configurable threshold. So it should be possible that you can define how many owners do I need to perform an action with the safe. So this is basically a multi-factor authentication. So it's, even if one key gets compromised, it's not possible that all your funds or assets get stolen, because you normally need more than one owner to confirm a transaction. The second thing was that you can replace owners, or like change the owners. So you can add new owners, you can swap out owners, and this allows you actually to do something like a very simple social recovery. So if you have the 6 owners involved in the Gnosis multisig, for example, and one of them loses a key, it's possible that 3 other owners just say, okay, we know that this person lost the key, so we replace this owner represented by this key with a new owner so that we can recover access for that person. And the last point that was already present in the first version was exception rules. So there are cases where we say, okay, it's not really required that we need multi-factor authentication for this transaction because it has such a low value. So there, Stefan added the daily limit, so up to a certain limit, you didn't have to use multi-factor authentications. So having this really nice wallet that worked very well for the company, we were thinking about, so how could we give this benefit to our users, to the users of our core product? And our core product are prediction markets, and prediction markets are generating outcome tokens, which potentially have a high value, and you want to use these outcome tokens to trade them using different market mechanisms. So since we have a lot of, since they can have high value and we want to interact a lot with smart contracts, we thought, okay, let's use a smart wallet to provide the same security and and even better interaction with contracts that we as a company enjoy with the Gnosis multisig. So that's why we started then, That's why we wanted to improve on this process, say we want to provide also multi-factor authentication as for our Gnosis multisig. We also want that the user can use some form of recovery. We have to see how that exactly works. And we also want to improve the contract interaction by optimizing the gas and allowing to batch transactions. And that is why we started developing the Gnosis Safe. So this is a completely new set of contracts, and the target of this contract was that we drastically reduce the gas usage, that we have the same level of security or even improve it and allow a more fine-grained control of access, and also improve the usability so that it's easier to use. Like we have seen in the talk from Austin, that there is a lot of things that you can do. So how did we reduce the gas? So the first thing that we did is that we actually store no data on chain anymore. So in the previous version of the Gnosis multisig, Could we get the screen back? So in the initial version of the Gnosis multisig, we were actually storing all transaction data on chain. So if you want to perform a transaction, you normally interact with an address, you send some funds, you send some data, and all this information was stored inside the contract, which actually takes up a lot of storage, and the user had to pay for this. With the Gnosis Safe, we decided against storing any information on the contracts or any information on chain. This allows us to drastically reduce the gas usage, and additionally also adds a layer of privacy, since even before, like in the old multisig, before the transaction was really executed, the information was already public on the blockchain, while with the Gnosis Safe, will only be propagated once it's really executed. The second thing is that we allow for off-chain signatures. So before it was, if you want to confirm a transaction, you have to generate the transaction hash, which you, can I do this? Oh, yeah, cool. So I take the information of the transaction and all the meta information, generate a hash, all the users have to sign, all the users take this hash, confirm on the contract that we really want to execute this transaction with this hash, and once all the users have confirmed it, then we could perform a transaction to actually execute the transaction through the multisig. With the Gnosis Safe, it's possible that you use this hash to generate an off-chain signature, so there's no requirement to actually perform any transaction on chain, and then only once you have all the signatures gathered, you send them together to the contract, so only one transaction is required. Another thing is that there is still some information that we need to store on chain that is more related to the contract to avoid that you can replay attacks, right? If you have the signatures, and if you submit them again and again and again, and they are valid for the same set of parameters, you could replay the attack. And for this, the only information we store on the contract is the nonce. So the nonce is similar to a normal Ethereum account nonce, which will, with each transaction, will increase it by 1, so that you cannot replay the attacks. Before, to do that, we had to have our transaction information again, where we had the executed state, and we had a mapping with a confirmation. So there was a lot more information actually stored on-chain to provide this security. So the next thing that we wanted to improve was like the security and the access control. And obviously the minimum requirement that we set ourselves was that you again have this multi-factor authentication logic, and that to improve this a little bit, we used it's very low level now, but we used the linked list, which is a little bit more gas efficient when iterating users and checking if somebody is an owner. And obviously we also provide the management functions that we had before, where you can add owners, remove owners, replace, and change the threshold. But additionally to that, we wanted to make the contract more flexible. So we wanted to allow it that you can define logic how the access to the contract is managed. And for this, we introduced modules. So you can enable modules, you can disable modules, and once a module is enabled, it is allowed to call the method exec transaction from module, which allows the module to perform a transaction or any transaction. So basically, what it allows us to do is something like a daily limit, where we say it's a contract, this contract has their own replay protection, it checks, are you an owner? Is a transaction you want to perform, is it below your limit for this day? And only once these conditions are true, we perform the transaction. So, another example would be the social recovery, where you say you define 5 friends, like 5 public keys, and only when a majority of these keys voted that an owner can be replaced, you can actually replace or like perform the replacement transaction, so gaining access by using your social friends. On the other side, now that we defined a way to extend the access control, we also wanted to have a way to extend the execution logic. So for this, we decided to introduce a possibility that you can perform delegate calls. So delegate calls allow you to take basically the logic from another contract and execute it in the context of your safe, or of your contract in general. What this allows us is something like multisend. Multisend is our library that we allow you batch multiple meta transaction into a big bytes data, send it to the multisend library, which splits it up into normal, like into single meta transaction, and then you execute all of them within one Ethereum transaction. This is very useful when we think about exchanges or even compound, where you normally have to perform multiple transactions before you get to the final result. Or like if we imagine an exchange where you first have to wrap Ether, then you have to approve this wrapped Ether that you can trade it, and then only you can really trade. And performing all of these in one transaction allows you that it is autonomous. So if one of these steps fail, none of the other one will be executed. One of the other improvements that we focused on was usability improvements. So we wanted that it's possible to pay somebody else to execute your meta transaction. This is, for this, we introduced a couple of parameters that you can see here, and with this, we can basically define how much, like if somebody else takes your signatures and submits them to the contract, how much will you get paid for doing this action? So we can see here, we then calculate how much gas was actually used. So it doesn't matter if if the user or the meta transaction actually failed. We check how much gas was used, and then the person who submitted the transaction to the contract will be paid for this amount of gas. And the last, but also very important improvement was that we decided to use proxies. So this actually touches all three areas. So it's security improvements, since now with a proxy, there is a logic that we can upgrade the contract, allowing us, if there is something where we have to do a security fix, users can actually upgrade their contract to a new logic without having to shift over all their funds. Also, it touches gas optimization, because deploying the whole Gnosis safe contract costs around $20 currently, and if you use a proxy contract, it's below $2, so it's a 10x factor of cost improvement. And obviously, it's also a general usability improvement, since we constantly are adding new functionality to the core contracts, and then the user can just upgrade to make use of this functionality. So how are we doing that? It's very simple. We have a very small contract where you define at the first variable a master copy. This in the same position, also on the master copy, we define the variable master copy, and then we provide a function which basically which allows us to set then the address of the master copy. So when we upgrade to version 2, we can just point it to the new version. So if we want to summarize it, like from how did we go from the old Gnosis multisig to the new Gnosis safe? So the old multisig was not very, like it had a very high gas usage. All transaction information were stored on-chain. You could only use on-chain confirmations to on-chain, like you had to use transaction to confirm on-chain the transactions, while when you use the safe, which is very optimized on gas, we don't store any information on the on-chain, and you can use off-chain signatures to save gas when confirming transaction. Also, the Gnosis multisig was not extendable. So if you wanted to extend logic, you always had to write a new contract, extend from the base contract just to introduce new functionality, and it was not possible that you use like a delegate call to pull in new execution logic. On the other side, the Gnosis safe was written with the purpose was for it to be extendable. And we had there the two ways that I presented. There was the modules to extend the access logic, and we had the libraries to extend the execution logic. And the last thing, which becomes more and more important, is really the improvement in usability. So before it was, you had to have some Ethereum knowledge. You had to have your own external account, which you fund with Ether, and you had to deploy the contracts yourself, and there was no way around that. While with the safe, since we have the refund logic and we can use signatures, it's not really required that the user in the end has any account with Ether on it besides the safe.
All right, thank you. Let us now take a look at how these contract decisions or design decisions basically influence the actual UI and UX. We will take a look at the Gnosis Safe for individual users and then compare that to the Gnosis Safe for teams, which is our solution for teams managing funds collectively. First, the interfaces. So the Gnosis Safe for the individuals are actually mobile apps because, yeah, well, we learned that not everyone carries around their laptop on a daily basis, and basically there's a lot of people who would like to access their crypto on mobile. These are actually live on the Ethereum mainnet. You can download them on the iOS and on the Android store. The Gnosis Safe for Teams is actually the direct successor of the old Gnosis multisig. And this is actually a screenshot of the interface. So it was a web app, and the first version of the Team Safe will also be a web app because our user research has shown that for Teams, it's still a desktop use case, and they're not they're not all the time on mobile. We don't have that on mainnet yet. There's a Rinkipi testnet version available, and if you're interested in using that, go to our website and sign up for our beta test. We hope to have, or we plan to have, a mainnet version available until October. All right, the Gnosis Safe for Teams is designed for actually full flexibility and for full control. So you can create a multi-sig, specify the number of owners. You can add owners, replace owners, and we don't do a lot of things to abstract away the underlying tech. Because what we've learned is if there's really a lot of funds involved, people still are double-checking what's going on, and so that first version will have that. Also, you will be able to choose the basically owner wallet of your choice. So it can be MetaMask, it can be Wallet Connect enabled mobile wallet, and it could also be our Gnosis Safe mobile apps. In contrast to that, we made some different assumptions when developing the Gnosis Safe mobile app. So the scenario we had in mind was that users have barely more than 2 devices. So they have their mobile phone, which they have with them at all times, and then they have potentially a laptop. And so the second factor device that we use currently is a Chrome browser extension. Both of them have their own private key, and that private key never leaves the device. Thereby, we basically reduce the risk that this private key gets compromised. Now, when you want to make a transaction, first you start on your mobile device, and then you need that second signature in order to make it actually happen. We've learned that, having just this browser extension is actually a little bit tedious. So we are working on adding hardware wallet support. We have a working prototype using the status keycard, and which we also plan to have live by October this year. And we're also in touch with a team from Ledger to also support the Ledger Nanos. And we plan to integrate them in a way that you connect the hardware wallet directly to your phone without the need of having to go through some website and through your laptop again. Now let's take a look at the actual transaction flows, because this is where the differences become more apparent. This is the Gnosis Safe for Teams. So one of the owners wants to make a transaction, enter all the transaction info, like address, basically which kind of asset, and the amount. Then they sign that with their wallet, and then the transaction basically ends up in this awaiting state. Now, at this point, it's waiting for other signatures from other owners, basically, to appear, so they need to be collected. And this can take anything between a couple of minutes to even several days or weeks, because, the owners or the team members are not always in the same place. Once they basically get notified about the transaction, they also sign it with their wallet, and then one of them has to submit it to the Ethereum blockchain. Actually, in the Gnosis Safe for Teams, the owner wallets pay the transaction fees. In contrast to that, in that Gnosis Safe for individuals, the beginning is actually exactly the same, but then when the second factor when the second signature is needed, we don't allow the user to leave the flow if they can only cancel or they need to successfully submit a transaction. Because our assumption there was if a single user wants to make a transaction, well, they have all devices or all authentication devices handy, and there's no need to wait. So essentially, their browser extension gets notified. They confirm there as well. The signature gets returned to the mobile app. The mobile app signs the transaction as well, and then it gets submitted to the Ethereum blockchain. Transaction fees here are paid from funds from within the Gnosis safe. So we do use meta transactions. We do use a transaction relay service for that. You can pay your transaction fees not only in Ether, but also in ERC20 tokens. Now, what are the current challenges that we faced? There's a lot of great tech, there's a lot of great ideas, but why haven't we seen more adoption of the Gnosis Safe and actually of smart contract wallets in general? First, they're still pretty new, so people are just much more comfortable with what they have been presented first when entering the space. This is in most cases still MetaMask, but it could also be any other wallet. Usually they are single private key-based wallets, and so this is a challenge. Then there's some concerns about security. First of all, there's this "it won't happen to me" syndrome. So when you have just a single private key, if that one gets compromised or stolen, well, then you could right away lose access to all of your funds. If there's more than one, it won't happen, at least that easily in that case. But people just think, it won't happen to me, and so that's why they don't see the need yet for smart contract wallets. Then the other extreme is that people are there's concerns about security, and they are not sure that the smart contracts are secure enough. They still have the parity multi-sig hacks in mind, and they think this could happen as well. Of course, we're not able to reduce the risk to basically 0%, but we mitigate that issue by letting third-party auditors auditing our apps, and also we had runtime verification, perform formal verification on the Gnosis Safe smart contracts. And basically we believe trust will come over time. Most importantly though, the full potential of smart contract wallets has not been leveraged yet. What does that mean? Essentially, there are some features unique for smart contract wallets that just cannot be replicated one-to-one with regular private key-based, single private key-based wallets. First, there's improved access control. The first example is the multi-factor authentication that I've been explaining earlier in this presentation. The Gnosis Safe does support that. Then you can define more advanced access control schemes, spending limits, transfer limits, that you can maybe spend up to 0.1, 0.5 ETH without requiring a second factor. And also you could work with whitelist and trusted contracts and stuff like that. In this category, a very important dimension is also seedless recovery, so basically recovery options beyond just the backup of your recovery phrase. The classic example is, social recovery, where you just specify a group of friends that could vouch for your identity in case you do lose access to your funds. The second big unique feature for smart contract wallets is are meta transactions, so basically the fact that you can allow third parties to submit your transaction on your behalf. So you have signed it first, and the smart contract does basically check if you're allowed to make this transaction. And this allows us to implement these so-called gasless transactions, so basically that the wallet pays transaction fees on behalf of the user. Long-term, or more practically, we can allow dApps to pay these transaction fees. In the Gnosis Safe, we have opted for the solution that you can use, besides Ether, you can also pay transaction fees in ERC20 tokens. This is especially important for onboarding new crypto users. For example, when you get onboarded with your burner wallet, you have XDAI on the XDAI chain, then you transfer them via the bridge to DAI on the mainnet, and so you would need Ether or a gasless wallet in order to make a transaction. With the Gnosis Safe, you could pay the transaction fees also in DAI. And last but not least, smart contract wallets allow you to simplify interaction with other contracts. The classic example here is, again, interaction with Maker CDP, with a Maker CDP portal. So in order to open up a CDP, you need, well, anything from 4 to 7 transactions. And, but for the user, it's just a single business action. So we could batch them together via the use of Delegate Calls, and the user just has to sign a single transaction. All right, please download our apps, try them out, let us know what you think. And if you want us, if you need some tokens to pay the deployment costs and to pay for transactions, please find us upstairs at our booth. We're happy to sponsor them. And yes, let us know your thoughts. Thank you. Good.